Well, I have some responsibility here in this Russian mega project, the laboratory of biomonitoring. So I'm a Norwegian, retired professor, but still working, and I teach at the University of Life Sciences in Norway on the aspect of chemical pollutants and human health. So during a PhD summer school program last year here at NARFO, I was challenged to address the effect of global warming on human health. So I was kind of asked to present this for the students. So this is my personal view. I am a chemist, but you know that chemists, they can be used as potatoes for everything. So you may agree or disagree, or I may seed some ideas and add to your already basic knowledge in this topic. So we will shortly discuss the causes of climate change. We will look into the effects due to the change in the climate, on the ice, which is important, for example, for the Arctic region, in the effects on precipitation, the rainfall, effects on organisms and especially on humans, and how we may influence in the future on the global change in temperature. So what is global warming? It's not a new issue because during so many years it has been change in the global temperature. But over the last decades, certainly this is nothing new to scientists because they have, for example, from the 1920s, shown that there is a continuously increase in the average global temperature. So another evidence of the increase in temperature is that the spring in general arrives earlier. And that the last years, in the last decade, has been the warmest in many, many years. So the real issue of discussion, is this something which is naturally occurring, or is it as well an effect which is enhanced by human activities? And if human activities is involved, is the carbon dioxide emission important? So is it some effect due to the nature itself? We know that volcanic activities have a huge impact on the global temperature. And we know that the energy coming to the planet is coming from the sun. So the sun activity is important, and the effect of the evaporation of water, the amount of water in the atmosphere, and the present as clouds. So some believe that the temperature increase we experience now is due to the position of the planet to the sun, which is known as the Milankovitch cycles. And you can see historically, it is proven that this is important for the temperature change. And is this generally accepted that in addition to potential natural effects that human activities may cause global warming? So here is two important politicians which have their own opinion. You have heard about Trump, who says that the concept of global warming was created by and for the Chinese in order to make US manufacturing non-competitive. And this country's president, he confessed at the last year Arctic Forum meeting here in Arkhangelsk that he was not supportive of a human effect to the global warming because it started already in the 1930s or 20s. After one day visiting a glacier at St. Joseph's Island. So it is not easy to convince all politicians that human activities are important. So what is the scientific base for focusing on this emission of gases into the atmosphere? If you look to the carbon dioxide concentration, it has slowly increased in the atmosphere over the years, as well as the methane. You know that methane is a greenhouse gas, which is, for example, highly emitted due to the prompts made by animals, especially in the production of red meat. So agriculture is an important emitter of methane. And then nitrous oxide and some of the man-made hydrocarbon based on fluorine. Several greenhouse gases. And the causes of carbon dioxide increase is easy to understand because it's the release of carbon into carbon dioxide by use of fossil carbon, oil, coal, natural gas. And over the years, it has been steadily increasing, and it's important because the carbon dioxide molecule are able to absorb heat which should be emitted back into space. So the increase of carbon dioxide molecules certainly will prevent the heat to leave the planet again. So what is the scientific consensus and the modeling of the potential effect of the increase of carbon dioxide in the future? Because now we are into understand what will happen in the future. So if you look, for example, into the half-lives of the greenhouse gases, we see that, for example, the change in carbon dioxide has been large during this period from 1750 up to 2005, and show you later the real concentration in the atmosphere, with a half-life something between 50 to 200 years, which means that if we stopped all emission of carbon dioxide, it will take this time period to half the concentration again. So that's an important issue, the half-lives of the greenhouse gases in the atmosphere. So who is responsible for all this continuously increase in carbon dioxide? And of course, you know it already, that's human activities. But we have other human activities and natural occurring events which cools down, and that's the emission of particulate matter. So particulate matter may as well slow down the increase in global temperature. And you can every month go into this website and look into the carbon dioxide measured at the Mauna Loa Observatory at Hawaii. You see that it's a seasonal fluctuation, lowest in winter, highest in summer. But when I prepared this slide in July 30 last year, it was up to 403 ppm. And I can guarantee you, if we go in today, it will be higher. So it's still a continuous increase in the carbon dioxide in the atmosphere, measured at different points on this planet. And here is a website where you can see the estimated or calculated global temperature. And in December 2017, it was to the very right. So the skepticism and global warming was developed, for example, in between 2000 and 2010, where in principle it was no indication of an increase in the global temperature, but we can see now for the last year it's starting to increase again. So the trend, as you see, is increasing. And everything of this global issue is related to energy. So we need to address consumption of energy as well. So, International Energy Agency, they give out annual reports. This is a board of specialists looking into the different area of production of energy and how it's used. And for example, if we compare the estimates from 1971 to 2014, we see that the total amount of fossil carbon, or the energy requirement, has been increased by a factor of 2.5. And we see as well the contribution in percentage, for example, from coal, which were 26% in 71, but decreased or increased to 29% in 2014. And oil has been decreasing. But in general, the amount of carbon released has increased in all these fields because the consumption has been larger. And we see that the field of use is not much changed. The industry is almost the same, the transportation, residential, so it's more or less constant, but it has been doubled in these areas. But it's interesting to see in the newest report from 2017 that they have developed now a rapid deployment and falling cost of clean energy techniques. So in fact, we are in a situation which they may reconsider their perspective. So I just wanted to focus you maybe to download this report and read it in more careful issue. And much is related to development in China. And in their perspective, they as well conclude that the real increase in need of energy will be in Asia and in as well much focus to India, which is rapidly developing. Another perspective made by another group of specialists, the World Energy Researchers, they have this presentation showing that from 1993 through 2011, and the estimate in 2020 is like this. The fossil fuel percentage is decreasing, but the absolute amount is increasing due to the increased need of energy. And they predicted in 2013 that the road ahead was much related to develop in China and the growth in the world population. Because the real cause of carbon dioxide emission is the user, the number of users. So if we look into the different countries responsible for the emission of carbon dioxide, we see that China and United States are large contributors. In 2011, Russia had approximately 5% of the total emission. Norway is not present there, so what we ever do in Norway has no impact. No, it's like a water droplet in an ocean, almost. And another issue which is under discussion as well is the footprints of human life in different countries. So we see that the cumulative carbon dioxide emission, historically, 27% from US and 25% from the European community countries. And many as well consider that to be important, because who should pay most to reduce their carbon dioxide emission, because they have emitted already much carbon dioxide in order to create wealth. And you may as well consider the lifestyle in the different countries to calculate the carbon dioxide emitted per inhabitant. In Norway, we live in a cold country, so we spend much energy, as well as in Canada and United States, because they have an additional type of lifestyle. And we see that it is approximately a large difference in the per capita emission, for example, between India and US. So with respect to the right to emit, who should be allowed to emit more carbon dioxide than others to develop their life? Another way, a trend is that over the years, China has increased the emission per capita. In the United States, it has been reduced as well in Russia. You can look this up further when you have the PhD file. Another prospective hypothesis in the future is by the Energy Information Administration in the US, and they predict the need for this type of energy into the next 20 years. In order to be able to cover the increased need of energy. And this is a Canadian view. And is it any reasonable alternatives to this sort of energy based on mostly fossil carbon? Well, we have this solar cell, the photovoltaic production of energy. And we have the windmills, which is rapidly developing in many countries. And we have the biomass, and then we have the geothermal energy. All these are considered to be environmentally friendly, with very much lower carbon dioxide emission. So the world perspective as well, they look into the production cost of energy, because the price is important for the development and change. So presently, the cheapest is large-scale hydropower plant. Norway is privileged because we produce all our electricity, 96% from hydropower, because we have much water, high mountains with waterfalls. And the new type of energy, for example, solar cells, are more expensive. But as you saw from the prediction of the International Energy Agency in 2017, that the cost of this alternative energy are rapidly decreasing. So maybe it will be a larger change than these boards have estimated in the years to come. But this is an important issue. This is the Global Carbon Project, who looked into the amount of emitted carbon dioxide and the recovery, and what is potential effect of more carbon dioxide to come into the atmosphere. So we see that the fossil fuel from the industry has made the largest emission of the fossil carbon. And it has resulted in an increase of this amount in the atmosphere, because what is released is as well stored in the ocean. It's absorbed by the oceans, and the land sink by recovery of vegetation is important. And we see that forest fires as well is one of a large contributor to the carbon dioxide emission. And they have as well estimated the total amount of carbon dioxide emission by year into the atmosphere. And they found out that in 2015 it was starting to level off, with a slight increase in 2016. And I think it's still an increase in 2017. So it's not any trend that it will decreasing in amount per year. It's still increasing. And this is part of the Paris Agreement, which you may have heard about. The Intergovernmental Climate Panel has developed a model, and this is what the politicians are discussing. How much should we allow of carbon dioxide in the atmosphere with respect to the average global temperature? So what they are discussing in Paris, we should not allow anything to increase more than 2 degrees. So that's the blue curve. And in order to obtain that goal, the emission need to follow that curve. And in 2016, we were there. So the situation is what will happen in the years to come with respect to the amount of carbon dioxide emitted into this model. And we see that China, over the last few years, more or less have stabilized their carbon dioxide emission. Maybe they are decreasing it. And most other main contributors are as well decreasing. But India is increasing because they have already a low carbon dioxide emission. And this is the situation per capita. And if they use this type of information in prediction, they conclude that in order to have a 66% chance to have an average temperature decrease lower than 2 degrees, they can only allow 800 gigaton of carbon dioxide to be emitted into the atmosphere. This is their calculation of the future carbon dioxide emission. What does this mean? This means that if we look into the emission pledges from US, China, and India, with their prediction in reduction, no other countries in the world should emit anything. So in their view, it's not likely that the Paris goal can be obtained, because it's so limited amount of carbon dioxide which can be emitted into the models to keep the global temperature increased by 2 degrees Celsius. And this is not any issue among the politicians. They still say that we go for the Paris Agreement. But that's very tough conditions. And the model, which is the blue one here, if this is the 2 degrees Celsius, we see that this will then end up with this perspective down here with the highest impact in the Arctic region. And you are already aware of that the largest temperature change is in the Arctic region. And that will be more and more severe if the average temperature increase more than 2 degrees. That with respect to the temperature change. Another issue is as well what type of effects this will cause. It is evidence that increasing temperature increase the precipitation due to more evaporation of water. So the Intergovernmental Panel on Climate Change, they focus that in their model that the lack of water may be a serious effect in Africa. I came from South Africa 3 weeks ago, from Cape Town, and there they advised us to drink wine, not water, because wine is more accessible. So we had to shower with a bucket under us to recover the water, which could be used to irrigation. So already there is serious areas which have experience with drought. And especially where the drought will be, it will affect the crops. For example, in Africa. So we know that the glaciers will melt. The effect will be a rise in sea level. And important for the environment as well is that they estimate that approximately 20 to 30% of all plants and animal species face increased risk of extinction if the temperature is above in this region of 2 degrees Celsius. So sea level will rise due to precipitation and local climate condition. We may experience more acidic rain and influence on the forests and agricultural production. And then we will see that the deserts will increase. And the weather will change. More storms, orcans, and they as well conclude that it's different to conclude what may be other effects. So they look into the modeling of the temperature effect and potential effects, environmental change. But what about human health? What is the serious issue with respect to human health? Well, the climate change certainly will have some influence on the weather condition, the heat, the precipitation, and that will, of course, have influence on air pollution, the pathway of contaminants, and then we have transmission dynamics, which is, of course, important for the biological hazards, bacteria, viruses, vectors, and the air pollution may be important in different places. So we see that, first of all, it has something to do with heat-related human effects and biological hazards. And rough weather conditions. Forget chemical pollution and such things and air pollution. No. So who are the vulnerable populations? First of all, the heat effects, elderly people, children, sick people, and extreme weather is those who have not optimal housing. And then we will see that the main focus here is water and food-borne pathogens and vector-borne pathogens, and especially those who these vector diseases which is commonly occurring in warm region. And then we are into a cartogram. Have you heard that cartogram? A map which is really showing where on this planet the largest impact on these climate change issues will be serious. And it's obvious that it's not any serious effect here in the north. It is in warmer region, in Asia and especially in Africa. So you see how this cartogram has been blown up with respect to the expected largest impact of climate change. What about heat events? Well, it is well documented that heat is important for human health. One good example is the heat wave in the middle of Europe in 2003. We can see that the land surface temperature difference in the red scale was large. And during a 2-week period, something between 35 to 50,000 additional deaths were identified due to the heat wave, and especially the elderly people. And there is a study, or several studies in US cities, where they show that the temperature is important with respect to the risk of mortality. And we see that the optimal temperature to have the lowest mortality is around 70 degrees Fahrenheit. Colder temperature, the Arctic temperature as well, is not healthy. And we see that the mortality increase with increasing temperature. So if we should predict the change in the Arctic temperature to be high, the temperature in average will change from minus degrees against plus degrees, and that may increase the life expectancy due to the increase in temperature. That could be a positive issue. Well, have you heard about the dengue? Yeah, it's commonly occurring, not here, but it's a fever like, not malaria, but it's a fever. And this is the global rise in dengue reported by the World Health Organization in this 50-year period. And it has been steadily increasing. And if you look into the information up to 2010, we see that it's still linearly increasing. And it's quite many severe dengue cases which is reported per year. And this is an important issue if the global temperature change is accelerating, because this is transferred by mosquitoes as well. So the breeding cycle of mosquitoes will shorten, so you'll have more mosquitoes. And it will spread from this region into the red region here, and you see that it's in this part around the Ecuador, which is affected. Warm places with higher temperature. And it will be the same thing with malaria. For example, this model from the occurrence of malaria in Zimbabwe show that from a high incidence in the red period, this will increase to almost the whole country. Just as an example of the effect on the distribution of malaria. And 2050 will look like this. But the cold region may experience a higher productivity due to warmer weather. But this will not outnumber the decrease in the total production due to the effect at higher temperature in the crop production. So the climate change impact on the rain-fed cereal production in 2080 is like this. We'll see that Russia will have a beneficial effect in the possibility of produce grain due to higher temperature, while other countries will have a severe decrease in the production. And if we look into the effect of the melting of the polar ice and the ice on Greenland, they estimate an increase in sea level. And this just shows the population density within and outside a 10-meter low elevation coastal zone. So in this, for example, region in Asia, this population will have a high influence of the rise in sea level. The Maldives will be gone. So already the government in Maldives have started to buy land in India in order to move the population.
Where?
Maldives.
Okay, but where they're going?
I don't know where in India, but I have read that as a strategy. What should you do? So migration of people is another effect as well, due to the impossibility to live on the land. So you can read this by yourself, and it is as well some prediction of positive things with respect to the change of energy. If we don't drive our cars and walk, we will be more healthy, and if we change from car driving to bicycle, yeah, it's many issues to be involved. And wildfire is associated with health, and you know that one of the main air pollutants with respect to human health is pollen. And pollen is expected to be more around to cause human health effects. So the key messages which we should focus on is that our health, of course, is tightly bound to the climate and the weather. It's cold outside today, so I wouldn't like to fall and be alone and break my leg and just be there at very low temperatures. And in cold countries, if you have too high intake of alcohol and fall asleep outdoor, that's commonly an effect or causative issue with respect to death. We have difficulty in understanding all effects in the future because our health is so influenced by different factors. Mitigation is important. We need to adapt and we need to change. And humans always found some reasonable solutions to changes. So the adoption process, of course, is important for the future. And I have given you some ideas where you can look up further information with respect to the view on impact on climate change and human health. And this is as well the latest issue from EPA in US. Donald Trump didn't want to have a 2017 report, so it was cancelled. But the 2016 report is available. So coming back to what I feel is an important issue as well. Do you see the clear association between the emission of carbon dioxide as a function of total number of inhabitants on this planet? And it is well accepted by not only this group, but here you see another presentation as well by other models. And this is the prediction of the global population up to 2050. Approximately 10 billion. What will happen with the blue curve? It's not easy to discuss this. You don't hear many politicians discussing the real cause of carbon dioxide emission. This is related to ourselves, the users. And for example, in US, with the highest emission per capita, this is the prediction of the population, which is presently today 325 million, up to almost 450 million in 2015. So the increase in such a population with this high per capita emission as well need dramatic changes in the production and use of energy. And I don't think you have visited this web page too frequently, because you have several of such pages estimating the world population. So it's ticking like a watch. So this is just a copy made, the date was November the 16th, 2016 at 09:58. So the US population then was almost 325 million, and the world population 3.35. And they calculated a birth every 8 seconds and one death every 12 seconds. So at this estimates that China was number one with respect to most inhabitants. And that was made a little bit later. And this is the most recent one, which I took out. The world population is now around 4.45 million. And the US population is 327. So it's increasing and increasing. We see increase in China, we see an increase in India. And India is coming closer now to China. And this was February 21, 2018. Population growth this year, in less than 2 months, 11 million. And this is the facts with respect to the most children per mother. And we see that all the first 18 countries are in poor countries, mostly in Africa. So the largest increase in population is in Africa. If you look to the right, you can look at detail when you have the copy. In Singapore is the lowest in the world, so they are decreasing the population. Russia is more or less stable. You have decreased it, but now I think it's more or less stable. So how should we then cope with the increasing population? And in my view, it's only one reasonable thing: to invest more to develop a better life for them, to remove poverty, because it is well shown that decrease in poverty decrease the number of children. And education. So I'm against all the billions of Norwegian kroner we spend to electrify our transportation system. I would rather see this invested in poor countries to develop a better life. Because whatever we do with respect to use of fossil carbon in Norway is a droplet. But we could have much more impact of our spending. But then you have the political discussion that, oh, every country needs to comply to the agreement at the Paris Agreement. So population issues need to be addressed. I don't know your view on this, but this is my personal view. So we need to have some impact, and we need to adapt to change. Of course, there will be changes. So, in conclusion, controlling birth rate and focus on economic development, energy conservation, new energy sources, and it is not done yet, but many focus on the sequestration of carbon dioxide to capture the carbon dioxide and store it, to transform it, for example, to calcium carbonate again. So that's end my lecture. So I hope that I have opened your eyes a little bit more to the complexity of this issue.